Okay, this is graphing sine and cosine, and this is the second video on this, and I'm going to graph a fancier one that involves changes in A, C, and D. I'll leave B out of it for now. So we'll graph a cosine function. We could have graphed either. Everything will apply to either, and we got to remember, these things from the first video. Now we'll be involving, because we're going to be shifting right or left, we'll be involving, talking about the left edge or where the function starts, the period starts, and the right edge where it ends, how to get the critical points. So you want to find all of these critical points, what they are, what angle measures on the x-axis. So again, our first video, we involved A and B, which changed the shape vertically. A changes the shape, and horizontally B changes the shape, either stretching or compressing the function. Now we're going to be involving C and D. So D moves the function up or down. So if we add a number on, it just shifts the whole function up. And if this is negative, it shifts it down. Whereas this is C here, which is inside the parentheses, shifts left or right. So the thing to recall is that outside the parentheses changes y, and inside the parentheses is a modification to x, so this is horizontal. And it's in minus format, so if x minus c moves at c to the right. If this said x plus c, it means x minus negative c and would move it by that many units to the left. So let's just do this example. Y equals 2 times the cosine of theta plus pi over 4 plus 3. So just identifying this, A is 2, B is just invisible, it's a 1 right here, so that's not going to change anything. C is negative pi over 4. Because this is a subtractive format, it'd be theta minus negative pi over 4. So that tells me that this is going to shift it left. And then D is positive 3. So this shifts it up 3, the function. This shifts it left by 4 units. And this stretches it vertically. So a vertical stretch by 2. So anyway, let's talk about what these are and use our vocabulary. So the amplitude is 2, and the new baseline or midline, I'm just calling it a baseline of the function. We could easily call it a midline. When I graph the cosine function, I'm talking about this line. On the parent function, it's the x-axis. It divides the graph vertically into a top and bottom half. It cuts it right through the middle vertically. So I would call that the baseline. So when we shift the whole function up or down, the baseline will go up or down. So the new baseline is D is 3. So the maximum value is if I start at 3 and go up by 2, the top of the graph will be at 5, and the minimum value would be if I start at 3 and go down by 2 at a positive 1. So before we talk about the period, let's start to put a picture to this graph. So I'm going to do mostly just the one period that's going to be to the right of the y-axis, and this is going to be shifted up, so I need more room up here. Okay, so the baseline is going to be at 1, 2, 3. So this is like the middle of the graph vertically, and the maximum value will be up here at 5. So it's really just up by 2. So the top of the graph will be there, and the bottom of the graph, the minimum value will be at positive 1. So that's down by 2 from 3. So everything's going to be, vertically in here. So now we'll figure out horizontally where this graph is. So the period is always 2 pi over b. And in this case, b is 1, so it's just 2 pi. And the left edge, or where the function is going to start, is at c, so at negative pi over 4. And the right edge, where the function, one period of the function will end, will be, I'll start at negative pi over 4, and I'll move to the right by 2 pi. So I'll end at negative 1/4 plus 2 would be 1 3/4, or 7/4 pi, or 7 pi over 4. So the left edge, if I just make this negative pi over 4, and if that's a fourth of 1, 2, 3, 4, 5, 6, 7, maybe 7 pi over 4 would be out here. So the right edge of the function now I know is going to be here, and the left edge of the function will be here. So everything's going to fit inside of that box right there. So let's find, those are 2 critical points, and then I need the 3 in the middle. So the halfway between negative 1 pi over 4 and positive 7 pi over 4, because those both have a denominator 4, halfway between negative 1 and positive 7 is 3. So because I can just add up negative 1 plus 7 is 6 and divide by 2. So 3 pi over 4 will be halfway between those two. Just the idea of a midpoint. And then halfway between negative 1 pi, and these are both over 4, so halfway between negative 1 and positive 3 would be half of 2, or 1 pi over 4, so that's going to be here. And halfway between 3, in the numerator, 3 pi and 7 pi is going to be 5 pi. So 5 pi over 4. Okay, so I have the 5 points I need. And then I remember that cosine is going to start at the top of the period and go to the middle, the bottom, the middle, and end at the top. So I'm going to start up here at positive 5, negative pi over 4, positive 5, and then this at the pi over 4, I'll be at the middle, I'll be at the bottom, I'll be at the middle, and I'll be at the top. So now I know that cosine cups down, and then it's going to go like so in this period, and then it's going to turn and go like so. So anyway, that's the graph of 2 times the cosine of theta plus pi over 4, kind of fancy. I'm doing a vertical shift up, by 3 units, a shift to the left by pi over 4 units, and it's got an amplitude of 2. And of course I chose my own scale, but you get the idea of where these points are. So that's it.